In the name of God. Hello, dear students. Welcome back to Ferkhaw's website. My name is Masoud. I'm a physics teacher. We are here in this site, in this website, actually, for explaining the physics curriculum, grade 12. Also, we have an application by the name of Ferkhaw's. You can download it on your cell phone to follow our videos. In previous lesson, we entered chapter 2 and we talked about some topics in this chapter. Right now, we are going to explain new subject, which is rotational and translational motion. So far, and especially in chapter 1, we have been familiar with rotational motion. But the word translational is a little bit, let's say, strange for us. We are not familiar with translational motion, right? So what's translational motion? Let me read the definition, and after that, I'll explain for you. Translational motion is the uniform motion without rotation. So uniform motion without rotation, in which the positions of an object changes continually. The position of object changes continually in translational motion. So like this bowling ball. This bowling ball advances to a new position without, let's say, without rotation. So it just slides across the, for example, across the surface. This is called translational. You see, it doesn't rotate. It just slides across the surface. It slips, right? There's a slipping without rotation. This is called translational motion, right? Teacher, is translational motion only dedicated for, let's say, rectilinear motion, or only rectilinear motion belongs to translational motion? Let's say, I can say mostly yes, mostly. But it's not, let's say, we cannot say completely. Mostly, translational motion means linear motion or rectilinear motion, but there are some exceptions. For example, think about the, let's say, translational motion of Earth about the sun. Does Earth, let's say, move about the sun in a linear motion, in a straight line? No. So sometimes translational motion, let's say, is a circular motion, right? So there are some exceptions, like what? Like translational motion of Earth about the sun. Actually, Earth orbits the sun in a, let's say, in an elliptical orbit. Yeah, an elliptical orbit. Actually, in this situation, moving the Earth along the elliptical orbit is considered to be a translational motion. So translational motion is not always, let's say, dedicated for linear motion. Maybe motion of an object, of course, without rotation. A sliding object on a curved path, a sliding, let's say, object on a circular motion, a sliding object on a elliptical motion are considered to be translational as well, right? But mostly translational motion is rectilinear motion on a, let's say, a straight path, right? This is about the translational motion. So we got information about translational motion means the object that advances, let's say, over time, right? So the second type of motion, and you are familiar with this, rotational motion, right? Rotational motion means the object rotates about a certain axis, like this spinning bowling ball. A spinning bowling ball about itself is an example of rotational motion. You are familiar with this. The third one, translational and rotational motion, is combination of translational and rotational motion. Like what? Like a bowling ball that rotates and advances to a new position, right? It slides across the table, across a surface. It slides, it slips, and simultaneously it rotates about itself. That's why it's an example of translational and rotational motion. Also, we can say that the, let's say, translational motion of the sun, of Earth about the sun, or total motion, let's say total motion of the Earth about the sun, right? It's a translational and rotational as well, right? It's a combination because let's say sun changes its position on a, let's say it slides across this outer space. It slides, so it has translational motion, right? And simultaneously it let's say rotates about itself. So I can say moving planets in general and Earth especially about the sun is an example of, let's say, translational and rotational motion. Translational means planets advance to new position, right? So this is translational because they change their position, right? And simultaneously they spin about themselves. They rotate about themselves. That's why it's rotational as well. So this figure, I think it helps us to understand the translational and rotational motion, and we can distinguish between these types of motion. Let's move on to another, let's say, subject, which is actually which is about it's related to our subject. It's not an independent subject. It's related to the translational and rotational motion. So in general, there are two types of objects, right? Objects are of two types. The first one, extended object, number one. Number two, point mass. Teacher, what do you mean by extended object? What's the meaning of point mass? Let me explain for you. So extended object means such as what? Extended object such as spinning bowling ball. You see, spinning. Whenever you hear the word extended, so extended is, let's say, associated with spinning, right? Extended object is associated with spinning. They are interdependent. Whenever you hear the word spinning, means rotation. That's why the object will be extended object. So a spinning bowling ball or a spinning let's say, pins of bowling, they are what? They are extended object. Even, let's say, pinwheel in a wind, the pinwheel actually rotates about itself. That's why it's considered to be an extended object. What do you say about the point mass? Point mass, such as free fall body. You see, free fall body. Think about the free fall body. Whenever you, let's say, you let this marker go, how does this marker actually fall down? Does it rotate or just, let's say, slide? So it doesn't rotate because it's a free fall. Free fall object does not rotate. Only they, let's say, they slide. Only they, let's say, slip, right? Without rotation. That's why free fall body in general are considered to be point masses. So in general, I can say any object. Well, before I read the definition for you, let's say by means of this example, let's say I got some information about extended object and point mass. Extended object means the object that rotates about a certain axis, like a spinning bowling ball. Let's say Earth rotates about itself. They are extended object. But point mass is an object that only slides across a surface without rotation, like free fall bodies in general, for example, a ball dropped from a roof. So they are all point masses because they don't rotate. So any object without rotation is considered to be a point mass. Or in other words, let me add another note. In other words, I can say point mass only has translational motion, right? Translational motion. Point masses only, let's say, change their positions without rotation. What do you say about extended object? Extended object, actually, I can say they have, let's say, a combination of motion. They have translational and rotational motion as well. Translational, sometimes actually translational and rotational motion together, right? Teacher, what do you say about for example, about the case that the object spins about itself without, let's say, advancing to a new position? It can be no problem. So either extended object, either is translation, let's say either extended object has translational and rotational together, or only rotational, let's say lonely, or only rotational. So it has, let's say, consists of two cases, let's say, two probabilities. Either the object spins about itself and it advances to new position. So this is, let's say, extended object, like the Earth that orbits the sun and, let's say, I can say rotates about itself. Or the object, maybe the object only spins about itself. It only, let's say, rotates about itself, like what? Like, let's say, pinwheel in a wheel, right? So let me read the definition for either object for you. Number one, extended object, an object that exhibits, that shows rotational and translational motion, such as rotating pins in bowling. Rotating pin or rotating bowling ball, they are all, let's say, considered to be extended objects, right? The second type of object is a point mass. So what's the point mass? An object that slides, it slips, right? It slips or slide, we can say slip or slide, they slip and slide along a surface. It means it has only translational. You see, it has only translational motion, such as a pebble dropped from a hill, right? A pebble, a stone dropped from a hill, from a top of a hill. Actually, in this situation, a pebble does not rotate, only it slides, and it has only translational motion. And I told you, or you can say free fall bodies in general are considered, let's say, point masses. This is about the subject, guys. Thank you very much for watching this video, and bye for now.